Alright everybody, now it's time to do our rare earth metals group. I'm going to make my rare earth metals blue. You can choose whatever color you like. I come over here, and now these metals down here, they're a little funky, and in high school we're going to learn why all of the elements on the periodic table don't get to fit in right here, even though the atomic number of these down here really would make more sense to go here. This top row, though, is that blue row we're going to call the rare earth metals. And it's ironic, like a lot of things in science, they're called the rare earth metals because we used to think that they were extremely rare and found in only trace amounts, but then as we got better with technology, we discovered actually you can find them all over the place. They tend to just to be bonded with other elements to form different compounds. But the name stuck, and so we call them rare earth metals. These are metals. They're still solids. They tend not to be super special in terms of reactivity and electrons. And we're going to write down for properties. They tend to be just hard to find, and they can be radioactive because these atoms start getting to be such a size that it can be hard for them to hold together, and they want to give off bursts of energy and particles and shrink down to smaller sizes. So for instance, all right, so for our properties for rare earth metals, instead of writing hard to find, which I did then realize, wait a second, it's too early in the morning. They're not hard to find. That was why we named them that, but they're pretty common out there in the crust. Some of the cool things that a lot of these are used for is they're used for lasers, which is awesome. And they're also used for magnets because they have strong magnetic properties. So that's pretty cool. And I'm going to write down my favorite rare earth metal. That's just fun to say. Ytterbium. Yeah, have fun spelling that one. Ytterbium. Named after the town in, I want to say, Sweden that it was found in. And ytterbium is just really fun to say. And it proves the periodic table is super cool because you get to say fun words like ytterbium. There you go, rare earth metals. All right. Now let's talk halogens. My halogens I'm going to highlight in gray, and I'm going to come over here, and my halogens are, where's that periodic table going? Here we go. Halogens are this column, not the farthest one on the end, but the one right next to it. These over here are our halogens. Now halogens they're fun because they're a combination of metals, nonmetals, and gases. And this is where it would have been really nice if I would have given you a real periodic table. These right here, these are all nonmetals. However, bromine, somewhere here in the middle, that's our only liquid metal. Isn't that cool? At room temperature, it's a liquid metal. And then when you come down here to the bottom, we get iodine and astatine, which are solids. So we have solids and liquids and gases at room temperature. So we have metals, nonmetals, and gases. We have solid, liquid, and gas at room temperature. These are very reactive. In fact, we're going to say these guys are buddies with these guys right here. And the reason these guys are buddy is because they have 7 electrons. And those 7 electrons have something to do with these 1 electrons over here. And it's all about that 288 rule. We learned about drawing atoms last week and how if these guys could get 1 more, then they would be happy, and these guys want to give away 1. And so these guys tend to like to react with each other and then get super chill and not get reactive anymore. I don't want to tell you too much more than that because I don't want to steal the thunder of your high school chemistry teachers, but we just need to learn for 8th grade, halogens are very reactive elements by themselves, crazy, fluorine and chlorine, burn your skin, scary thing. In fact, let's write those down. You know, chlorine is a favorite one, found in pools. Fluorine is super reactive. Now, by themselves, they're going to hurt you, okay? But, you know, we combine them to do cool stuff, like we put fluorine in toothpaste to keep your teeth clean. We put chlorine in pools, you know, to kill all the bad stuff and the bacteria, but we don't put too much chlorine or it's going to harm us. All right, and now we got 2 groups left. We got our noble gases, which I'm going to highlight in normal neon highlighter or yellow. And our noble gases on our periodic table on the other side, we're going to highlight in this neon-y color. neon for noble. And then what we're going to write about noble gases, since they're gases, they are a G for metal nonminor gases. They are gases at room temperature. They are not reactive at all. That's why they're called noble gases, actually, because they're sort of like kings and queens, and I don't talk to you and I don't react with you because I'm a noble gas. I'm happy with all my electrons. These tend to be colorless gases unless you run a current through them, and then you get all sorts of cool things, you know, like neon. Let's take a look at the periodic table. Oh yeah, and argon. And then they light up with really, really cool colors. So yay, found in signs. That's what we like to use noble gases for. And then the last, I saved you the best for last, because this one's a pretty goofy one. I'm going to highlight this in my blue pen. I got metalloids down here. Now metalloids are a really weird stair-steppy sort of group. What I want you to do with your periodic table in your notebook is start with aluminum, who's right about here. And I want you to do a 1 over, 1 down, 1 over, 1 down, 1 over, 1 down, 1 over, 1 down, until you run into those halogens. And then you've made your stair step of metalloids. And the reason these are called metalloids is because this group right here came from our transitioning, remember these are transition metals. These over here are alkali metals, alkali earth metals. These were our rare earth metals. These metalloids, we are transitioning across to all of these non-metals up here with our halogens and our noble gases. And so these are sort of like metals, but also they act sort of like the non-metals up here. So here's their unique characteristics. They are metals, and they are solids. Well, we're going to put an N, we're going to write them metalloids, because though they act like metals, here's why they tend not to be. Over here for properties, we're going to write down, though, they're solid, but they're brittle. So they're not good, strong metals. And they are semiconductors. And so semiconductors mean, we have up here these transition metals who are magnetic and they're useful tools and they're good conductors. These guys as semiconductors mean, just like a semicircle means half, they're only half good as conductors. Now this is actually good for some things though, because I'm going to do a little slash here for reactivity. That's not their game. But for our examples, for instance, silicon. I mean, you guys love your cell phones, right? Because you have these computer chips that can conduct electricity, but they don't get super hot or burned out, which is great. That's what you need for your cell phone. Nobody wants a cell phone that's burning up in their hands. So we use a metalloid, a semiconductor. So yay for semiconductors that make electricity possible. Well, folks, you just survived about 15 minutes of periodic table organization. We should have a pretty colorful chart on our right. We should have a somewhat colorful periodic table on our left. Congratulations. Now we're going to do some more fun stuff with our periodic table. Go science! Thumbs up.